So it starts with the first with some of the applications about the pressure, like what is pressure? Like if you increase the pressure, how that's going to change things. What is atmospheric pressure? Atmospheric pressure is the pressure that is exerted by the air. What happens if you go up in the higher altitude? What happens to the atmospheric pressure? Increases or decreases?
Decreases.
Decreases. So let's say if you are at the lower levels, if you're at this lower level, you have all this air that is going to put pressure on the surface. And if you are standing here, but if you move up and you come to this area, then only this amount of air is putting pressure. So atmospheric pressure is a pressure coming from the air above. So if you're higher, whatever is left behind down here, it doesn't put pressure on this level. Only everything that is higher than this level, it would put pressure. So it makes it lower pressure as you move to higher altitude. The pressure is basically a force that is coming from the gas, as the gas molecules are in constant motion. When they hit the wall, they hit the surface, they cause pressure. Pressure, by definition, is force over area. So the force is coming from gas molecules that are hitting the wall of the container, hitting the surface, and the area is the surface or the volume. So pressure of the gas basically is the force that is applied per unit. Some effects of the gas, effect of the gas pressure. The bigger the difference in pressure, the stronger flow. Means that if you have high pressure in one area, low pressure in another area, the gas is going to start moving toward the low pressure. So you have the gas flow. If there is something in the gas path, it can probably move that also with it. So the atmospheric pressure, or the difference in the atmospheric pressure, it can result into in weather and wind patterns. That's based on the atmospheric pressure. There's some facts that you need to know as a connecting what you learn inside the class to outside environment. So the hope is that it will make it more interesting. So what happens if you have rapid changes in the atmospheric pressure? It can cause your air pop. So when you talk about pressure, is basically change in pressure that can cause different things. A pressure of a gas is based on the force that the gas molecules are applying to the surface of the container. If it's a closed container, you can measure the gas pressure. The container must be closed. Please know that if the container is open, the pressure inside the container, it equals to atmospheric pressure. So you go back to atmospheric pressure. You don't go to the pressure of the gas itself. So the pressure of the gas depends on what factors affects the pressure of a gas. So if pressure is force over area, the higher the force, what happens to the pressure? Direct proportion or inverse proportion? Higher the force, you don't change the area, you increase the force. What happens to pressure?
It increases?
Increases. Okay, very good. What happens if you increase the area? If you increase the area and you don't change the force, what happens to pressure?
Lessens.
The pressure would be lowered. Yes. So what happens if the molecule starts moving faster?
Pressure increases.
If the pressure, and can you tell me if the speed is higher for the molecules, how would that affect the pressure? If you increase the speed, that means kinetic energy is going to increase, right? Kinetic energy depends on the speed and the mass. So you increase the speed of the molecule, kinetic energy is going to increase, and that is going to increase the force. So some questions are like directly coming from this or related to this formula, other are like indirect information. What happens if you increase the temperature? What do you think it would happen to pressure if you increase the temperature? Temperature is good. When temperature increases, then molecules, they have more kinetic energy. They are going to, gas molecules, they have more kinetic energy. They are going to move faster. So the V is going to increase as a result. And then when the V increases, then F is going to increase as a result. That's the force that is going to increase. And force increases, then pressure is going to increase. You see how it's related? Temperature increases is going to increase the velocity or speed of the gas molecules. If the speed is higher, then the force is, from this formula, force is going to be increased. And if the force is increased, pressure is going to be increased. Now, if you lower the volume, of course, we already said, if you lower the volume, then if that means you are lowering the area. If you lower the volume, then the force is the same. You're dividing the same force to a smaller area, then the pressure is going to be higher. So there are factors that is going to affect the pressure of the gas. Those are some of the factors: temperature, volume, and number of molecules of the gas. Units that they are used for measuring the pressure, it's ATM, millimeter mercury, and millimeter mercury or inch mercury. Basically, what is or how is measured? If you have this barometer, barometer is like a tube, a glass tube that is inverted with the open end, inverted into a container or open container of mercury. The atmospheric pressure that is here, this atmospheric pressure is going to put pressure over this mercury, surface of the mercury. And since there is pressure over that, the mercury is going to go up in this glass tube. The more pressure, what happens? The higher the level of the mercury is going to be, because you're putting more pressure on this surface, more mercury is going to go in. So then you read this number, the level, and if it goes up like 760 millimeter, or if it goes 76 centimeter, then you read it that it went up by 76 centimeter or 760 millimeter. And that's the height of the mercury. That's why it's called mmHg, millimeter of mercury, or inch of a mercury is the same thing. Basically, you are measuring the height of the mercury in this, in that tube. The higher the pressure, the higher the height of that mercury in the tube is going to be. The units that are used, it could be Pascal as a unit, kilopascal. So as you see, there's just 1,000 difference. And then atmospheric pressure is like a pressure exerted at sea level. So if it's at the sea level, it's going to be 1 atm. And 1 atm, these are the everything that you have here. That's the relationship between the units, how they are related to 1 ATM, basically. Okay. So that's the average air pressure at the sea level is 1 ATM. That equals 1 ATM. That's why it says if you express an ATM, is going to be exactly 1 because pressure at the sea level is 1 ATM. The higher you go, pressure is going to decrease. That atmospheric pressure is going to decrease. And these are the different units. Understand that the 760 torr is the same as 760 millimeter mercury, and that equals to 1 ATM. And then other numbers for the exam, it will be provided for the, you need to make sure you just know the relationship. But the actual value, you don't have to memorize it. Okay? But you have to memorize the millimeter mercury. If it's 760 millimeter mercury equals 1 ATM, and that equals to 760 torr for every ATM or 1 ATM. And be able to convert it. How would you convert it? You just use that table, and from the table, you write your conversion factors. You start with the given unit. So if the PSI is given here, PSI is given, and you want to go to millimeter mercury, you can use from this table, and the PSI or pound per square inch, PSI 14.7 is 1 ATM. You can convert this to 1 ATM, to ATM, and then from ATM, you can convert to the millimeter mercury, as long as you know the relationship between them. The value for PSI, of course, you don't have to memorize it, but it's 14.7 PSI for every 1 ATM, but you need to know that 1 ATM is 760 millimeter mercury, is basically converting or conversion factors. So we talked about the barometers that measures the atmospheric pressure. And we also have a manometer. Manometer measures the pressure of a gas in a closed container. So in a closed container, if you attach a manometer to a closed container, you can basically measure the pressure of the gas. How does it work? The higher the pressure is here, the higher the pressure is going to put more pressure, and then the mercury is going to go up higher. So you see the difference is going to be greater. So that's how manometer works. So it's going to be, if it's at atmospheric pressure, so if the pressure inside and outside is the same, the level of the liquid that you have at the U-tube is going to be the same. So you would have something like this, same level. Now, more pressure comes in, this is going to be higher. So when you are recording, when they are recording the pressure for the gas, they say, if this level, if the left arm is higher, that means the pressure is higher than atmospheric pressure. So they say atmospheric pressure, whatever it is, plus the height, that gives you the pressure of the gas using the manometer. Okay, Boyle's law or gas law, you get a lot of questions about this in the assignment. Gas laws, these are a set of few laws or formulas or equations that is going to show the relationship between pressure, temperature, volume, and number of moles. You knew about the temperature already, have to measure temperature. You know about the volume, number of moles, mass divided by molar mass, that gives the number of moles. The only thing that is kind of new to the measurement for gas and is unique for gas is pressure. So these four different characters, they are related to one another. And we do have one formula actually that relates all of them for any given gas. is called PV equals nRT. That's the pressure in ATM, volume in liter, temperature in Kelvin. Remember, temperature, whenever in any law for gases is in a question or equation, you must use Kelvin temperature. You cannot use Celsius or Fahrenheit for it. And N is the number of moles. So it's just a number. I gave you the last law first, so you see that these four are all related. And this formula for ideal gas law is used for one condition only, okay? One condition. So what happens for the Boyle's law, or what is a Boyle's law? Boyle's law, it's talking about the relationship between pressure and volume. And it says, if you increase the pressure, volume would go down, okay? If you increase the volume, pressure would go down. So these are indirectly proportional. So if they are indirectly proportional or inversely proportional, either if they are inversely proportional, but what would be the formula? They are, if you increase the volume, pressure would go down. But how much is going to go down? It would go down enough that will give us this equation, that the pressure times the volume is going to be a constant. Under what condition? Under the condition that temperature and N, T and N must stay constant, okay? Must be constant. You cannot change the volume and also change the temperature and use the Boyle's law. Boyle's law is used to use the Boyle's law. Temperature and N must be constant. Okay? So P1V1 equals P2V2. This is the primary condition of pressure and volume, secondary condition for pressure and volume. So if you have the pressure and the volume of a gas sample of the gas, if you change the pressure, volume will change. How much is going to change? It's going to change enough to give the constant value again. So P1 times V1 equals P2 times V2. So that's the equation that you're using, but you have to understand and recognize and diagnose when can you use this Boyle's law. You can use the Boyle's law if the temperature is constant, number of mole is constant, but either volume is changing or pressure is changing. One of them is changing. Okay. This equation or graph, it shows that if you lower you increase the volume, the pressure is going to be lowered. And if you plot a new graph, and that is based on the 1 over the volume, or the inverse volume, you get a linear shape of the graph. So pressure is directly proportional to reciprocal of the volume, or pressure is inversely related to the volume. You increase the volume, pressure is going to decrease. So some of the examples, what happens here? Pressure goes up, volume is going down. Pressure would go up, volume is going further down. But in any given set, if you multiply the pressure times volume, you're getting the same numbers. So just using a graph to show you that they are related, using a graph to show you, and then using numbers to show you that they are, pressure times volume is a constant number. If temperature stays constant and number of moles stays constant. So we know about the Boyle's law, and we are going to do example with the Boyle's law, solve problem with the Boyle's law. So we can start your assignment right away, or if you have not started yet. So what happens if you increase the volume? If you increase the volume, pressure is going to be lowered. But if you decrease the volume, pressure would be increased. So if the volume is half, pressure is double. If the pressure is half, volume is double. An example, a cylinder with a movable piston has a volume of, so we know that P1 value is given to us and it's a 7.25. So when you read the problem, since it's already written here, I don't want to read, I would do the second problem. I'm just going to go over the solved problem. What is the key when problem solving with the gas laws? You read the problem, you write your information. Okay, so as you read this problem, cylinder with movable piston has a volume of, so we know that volume is 7.25 liter. And pressure is, and the P1 is 4.52. What is the volume at? So P2 is given to us as 1.21 ATM and is asking for secondary volume. How do I know I have to use Boyle's law? So I have to recognize which law I'm using, because if you only know about Boyle's law, you use Boyle's law. But if you know Boyle's law, Charles' law, Avogadro's law, Gay-Lussac law, and ideal gas law, which one are you going to use? So you have to make a table for yourself, know that, and recognize what needs to be used and what needs to be used, which law needs to be used or which formula needs to be used. It depends on what information is given, what stays constant. So there is no word of temperature. So they didn't say anything about temperature. They didn't say anything about number of moles. If there is no information about temperature or the number of moles, that means those two are constant. Okay. If they are constant, then we know that we can use the Boyle's law. And what is Boyle's law? P1 V1 equals P2 V2. You have the list of all data. You recognize which formula you have to use. Then you just plug in the numbers. Now, if pressure P1 is ATM, P2 must be also ATM because it's an equation. The unit must be the same on both sides. Okay, so if pressure is ATM, pressure P2 must be in also ATM. V1 is in liters. Whatever number you find is going to be in liters. So pay attention in case if the equation is going to give you liters, but the question is a multiple choice and is asking for milliliter or gallon or something else, there's this next step that you have to, extra step that you have to follow. Okay, a balloon is placed in a jar and the pressure is reduced from. If it says pressure is reduced from 2, that means we have the P1 already, okay? So that's the P1 value, and this is the P2 value. If the volume of the balloon is now, is this a V1 or V2? Is it V1 or V2? Can you hear me?
Oh, did that not go through? I said 2.
Okay, perfect. No, it didn't. Use the mic. Okay, so it's V2. So this is the volume now. So it's going to be V2. Originally, it would be V1. There is no word of temperature or pressure. I'm sorry, temperature or number of moles. So we know that we are using P1 times V1 equals P2 times V2. So what else we need to do here? Can I use the numbers directly? Can I say P1 782 times V1 equals 0.5 times 2780? Can I use these numbers directly? What's the problem with it?
You'll divide the 0.5, or sorry, you'll divide the right side by the 782 to get your original volume.
Can I use these two numbers the way it is?
Oh, no, you have to turn the...
I cannot use it, right? I cannot use it because this is millimeter mercury, or this tour, and this one is ATM. There's no equality here. So first thing, I have to make sure the units of pressure or the given numbers, the unit of the pressure is the same. It must be the same.
And you have to divide the 782 by 760, right, to get ATMs?
So if I divide this by 760, then I can now say this is ATM, and the second one is given an ATM. Now I'm fine to use it. Then when you have this number, that would be like 1 point something, and then you divide both sides by this, and you get the value for V1. The solution is on the next slide, but I want you to recognize when you can use numbers directly and under what condition you cannot use those numbers directly. The indirect information is given, and you have to make sure the units are properly done. So when you rearrange the formula, you can rearrange the formula first or plug in the number first. So rearranging the formula, it already shows that that's where you have to put your numbers. V1 equals P2 times V2 divided by P1. But you also have to take this step and change the unit for pressure from tour to ATM to make it the same. Charles law. So Boyle's law, P1 V1 equals P2 V2 is used under constant temperature and constant number of moles. They don't change. Charles law, for Charles law, pressure and number of mole is constant. You see, you only have the volume and temperature. So pressure and N are constant. Okay, so pressure and number of mole must stay constant in order to use the Charles law. At constant and the amount of the gas, it should be pressure and the amount of the gas must stay constant. The temperature used must be in Kelvin. Okay, you can't use Celsius or Fahrenheit. And if it's the multiple choice, there is always a correct answer or matching answer with using Celsius or Fahrenheit. And then that would be a tricky, question, because the Kelvin the temperature must be in Kelvin. How do you convert to Kelvin? If the Celsius is given, you just add 273, and that changes to Kelvin. So V1 over T1 equals V2 over T2. If you know about cross multiplying, that's going to make it easier for you when you do cross multiplying. That means V1 times T2 equals, okay, T1 times V2. This is called cross multiplying. When you have equation, V1 times T2 equals T1 times V2, or V1 over T1 equals V2 over T2. In order to rearrange, okay, like if you're finding T2, how would you rearrange it? For T2 is going to be T1 times V2 divided by V1. So T1 times V2 divided by V1 for rearranging the formula. Or know that you can change the format in this way, or any way that you have learned in the math is fine. What I know in chemistry, that my chemistry concern would be that temperature must be in Kelvin, and this formula can only be used if the pressure and the number of mole is constant. Basically, based on Charles' finding, these are Boyle's and Charles, or Gay-Lussac. These are all chemists or scientists that they worked with the gases and they came up with these rules. They just came out like one rule at the time, and then they figured out, oh, well, they can actually combine all these and have like a combined gas law too. So based on this graph, what you see is that if you decrease the temperature at lower temperature, volume is going to be decreased. You increase the temperature, volume is going to increase. And if you lower the temperature enough and extrapolate that to minus 273 Celsius, minus 273 Celsius is the same number as 0 Kelvin, okay? The volume is 0. What does it mean? It means that at absolute 0, which is a negative 273, or 0 K, okay? This is a 0 K, 0 Kelvin. At that temperature, volume of gas is negligible. Volume of the gas is going to be 0 if the gas is ideal gas. Basically, I have to say this up front in case we didn't have time to finish it, is like gas, if it's ideal gas, the volume is going to be 0. That means, what does it mean is ideal gas? Ideal gas means that if you lower the temperature, it doesn't change to liquid. A ideal gas stays gas at very low temperature. And if it stays gas at very low temperature, it doesn't change to liquid or doesn't change to solid as you lower the temperature. The volume is going to be theoretically 0. Okay? That's for ideal gases. How do they come up with this formula then? It says that if you lower the volume, temperature would be lowered, or if you lower the temperature, volume would be lowered. So volume and temperature, they are directly proportional in a way that V1 over T1 equals V2 over T2. And this is the Charles law you are using for your calculation. Under what condition you are using it? If there is no word or no data regarding pressure and number of moles. And that's something happening in this equation. I don't see any pressure. I don't see any number of moles changing. It says the gas has volume, so that makes this V1. At the temperature, that makes it T1. The only problem is that this T1 is given in degrees Celsius, and you have to say plus 273 to make it in Kelvin. So you have to do that right away. As soon as you see this, run away from, or add 273 to make sure that is in the proper unit. What is the temperature at 2.8 liter? Okay, so if the temperature is question here, so we need the T2 question mark. That's what we are looking for, and the volume is given to us as the 2.80. So we are looking for a T1. The way that the equation is or the question is expressed, it shows that this is was and this is has. So if this one goes past, you can label the T1 is missing and the V1 is a 2.8. Or you could say the V1 and the T1, these are, just make sure that you don't mix match. These two are at the same temperature and this one is missing the temperature. So you have to read the question a little more carefully. Okay? So make sure that you're using the correspondence. Looking at an example here. Temperature inside the balloon is changed from, so we have from and to. So this is a T1. As soon as you see this, you have to say plus 273. You don't want degrees Celsius whenever you're dealing with thermodynamic or gas law. And then this is a T2 plus 273. The volume under the cold air at the low temperature is, so if V1 is 10 liter, what is the volume at the hot air? See, if the language is different. So you have to, when you do assignment in Newton, pay attention to the language and the type and vocabulary and the type of the questions that they are asking. Can I use Charles' law in this case? You have two choices so far. Boyle's law, P1 V1 equals P2 V2. This is when volume and pressure is given or asked. The other choice is the V1 over T1 equals V2 over T2. So based on the information given, you diagnose that the Charles' law is the equation that you have to use. And then you set up the equation. As long as the units are matching, and if you're using Charles' law, make sure that temperature is in Kelvin. And that's like a big deal. It has to be in Kelvin. Okay. So V1 is 10 over T1 is 298, which is 25 plus 273 equals V2, that is the question, over, what is this number plus 273? 273, that is a 500 and what? 523, I think so. And then you find the value for V2, and this is a 250 plus 273. So you know where it's coming from. And to find the V2, you would say 10 times 523 divided by 298. Whatever you find is going to be the value for temperature. Questions? Which is 17.5 liters. And it makes sense. The volume makes sense because we know that if you increase the temperature, the volume is going to increase. And the volume is almost double because you have increased the temperature. Avogadro's law, it shows the Avogadro's law, it shows the relationship between volume and number of moles. And in this case, we also have the molar volume of gases. Molar volume is 1 mole gas at STP equals 22.4 liter. Now, one mole gas at STP equals 22.4 liter. What does it mean? What does STP mean? Standard temperature and pressure. So it also means that, based on this definition, it also means that volume is related to number of moles if pressure and temperature is constant. You see, you are only dealing with two, volume and number of moles. The other two must stay constant. So pressure is constant, temperature is constant. If pressure and temperature are constant, then volume and number of mole is directly related. Now, if you have 2 moles, what would be the volume? If you have 2 moles, because this equation says every mole is 22.4, so 2 moles is going to be 44.8 liters. Half a mole, 0.5 mole, is going to be 11.2 liters. Okay. So as you increase the number of moles, the volume is going to increase, and vice versa. In this equation or this example, number of mole is given, volume is given, and then it says how many moles must be added to volume to be 6.48. So the question is not asking how many moles you have at the end, is asking is not asking what is N2, is saying what is the N2 minus N1. What's the difference? How much must be added? So pay attention to the question, because you already know Avogadro's number, and then you calculate N2 and you find that, and the answer choice and say that's the answer. That is not actually the answer. You have to find the difference, because the question is how much is added. Ideal gas law. We talked about ideal gas law briefly. It's PV equals nRT. This is equation that can be used to one condition. So we're not changing temperature, we're not changing volume, we're not changing number of moles, we're not changing anything. A sample is given, and for that exact same sample, if pressure, volume, and number of mole is given, you find temperature. So in this case, you have all 4 of them, plus R value, which is a gas constant. It's called universal gas constant. The value is given, expressed in ATM, liter, mole, and Kelvin. If any 3 is given, they are directly or indirectly, you can find the last one. So that's what the application for PV equals nRT is. If you have the volume, pressure, and you have number of moles, you can find temperature. If you have temperature, number of moles, and volume, you can find pressure. Under what condition you can use this? You can use it at any condition, but you want to make sure the units are proper and matching with this units of the R. You cannot have the R expressed on liter ATM and use the torr here or milliliter. So volume must be in liter, N is number of moles, and temperature must be Kelvin. The value for R is given value. Memorize it in case if the question doesn't include it, but often you get that. And when you say ideal gas, that means that there is no interaction between the molecules. There is no attraction forces between the molecules. When they hit the molecules hit each other, they kind of move away from each other. There is no attraction forces. And that's why if you lower the temperature, it doesn't change to liquid or it doesn't change to gas. That's what ideal means. how many moles of gas are in a basketball with total pressure? So we see that here, P is given and is not a P1 because it's just one setting, okay? And you have the volume, you have the V, and then you have the temperature. Are these units proper? Do I have to change any of the units? Which one is proper unit for using PV equals nRT? So we know 3 characters given and 1 is asked, number of mole is asked. So you must use ideal gas law. But in order to use ideal gas law, the units must be proper. Are the units proper or no? Temperature in Kelvin or Celsius? Which one? Temperature must be in Kelvin, so we have to add 273 here. Volume, is volume okay? And what about pressure? What should be the unit for pressure? ATM, and it's given as a PSI. So we have to divide this by 14.7 in order to change it to ATM. So pressure must change, temperature must change, the unit for pressure and temperature must change. Then we can use the PV equals nRT, and you can rearrange this. Of course, you can divide both sides by PV or use the numbers first. So you can rearrange this also in order to find the final answer. I said STP. So remember, STP is a standard condition. Standard temperature is 0 Celsius. This is for gases. And for thermodynamic, standard temperature is room temperature. But for gas law, standard temperature is 273 Kelvin. And standard pressure is 1 atm. If the pressure is 1 atm and the temperature is 273, 1 mole equals 22.4 liters. Okay. What type of information is given here is asking, it's given more than one item is changing, okay? What is STP? So we know that STP, standard condition, temperature is 273 Kelvin and pressure is 1 atm. So this is a P2 and this is a T2. Two thing has changed, two character has changed. So we cannot use Boyle's law and we cannot use Charles' law because both temperature and pressure is changing. And volume is going to change. So we have the V1, P1, and T1. We have the T2 and P2, and we need to find about V2. So if more than one item is changing, you cannot use Boyle's law, Avogadro's law, or Charles' law. Now you have to combine it. P1 V1 over T1 equals P2 V2 T2. This is known as combined gas law. For a combined gas law, you can change more than one item. Okay, what about the units? Do I have to change any of the units? Unit is not like ideal gas law in this case. It doesn't have to be ATM, it doesn't have to be liter, but what it has to be, because there is this equal sign here, units must be the same units. So if pressure P2, if I'm using 1 ATM, and the V2 is, and this is a 273 Kelvin, then T1 must be expressed in also as the Kelvin. So it has to be like a 300 Kelvin, because that is plus 273. And then the V1 liter, this is going to be liter, so we don't have problem with that, 10 liter. Pressure is given in PSI, and we have to convert that to ATM. So this is going to be 44.1 divided by 14.7 ATM. So units doesn't have to be ATM, but it has to be the same on both sides. If one side is ATM, the other one also has to be ATM. If one side is PSI, the other side has to be also PSI. So these are the diagnostics, like what you need to do in order to get the right answer in the for the question. The solution is okay. In this case, the solution is different, given differently, but I want you to also know the combined gas law. So what I had before, just use that equation to solve the problem, to find the V2, and then from that you can match with this and see that you're getting same answer. So you should get like same answer. If you use this way, you can find the number of moles from the condition that it is now. And then if you have the number of moles, then you can multiply by 22.4. That gives you the volume at STP. So basically the approach is different here. You find the number of moles. In order to find number of moles, you would use PV equals nRT, and then find the number of moles. When you have the number of moles, then you say, okay, if I have 1.2 moles at STP, what would be the volume? Because for 1 mole is 22.4 liters. For 1.219 mole, it would be X. And you can find this, or you can use the conversion factors. If you were using the conversion factor, 1.219 mole times 22.4 liters over 1 mole. That's the conversion factor. The mole would cancel. What happened? Wow. In my it's fine that I lost the PowerPoint. Okay. Questions? Any questions? No questions. Okay. About the molar volume, we talked beginning of this presentation, molar volume 1 ATM. I'm sorry. At standard temperature and pressure, 1 mole equals 22.4 liters. 1 mole of any gas at STP. And we talked about STP, and STP is 1 atm pressure, and the temperature is 273 Kelvin. So if you have 1 mole of helium, 1 mole of xenon, or 1 mole of methane, the volume is going to be the same at STP, regardless of the molar mass, regardless of the other factors, because the pressure and the temperature is going to stay constant. You can use that and to find the density, because if you know it's 1 mole, and if you have the 1 mole for like a CO2, 1 mole CO2, you can find the molar mass. 1 mole CO2 is 22.4 liters. 1 mole CO2 is 44 grams. So density is mass over volume. And at STP, volume is 22.4 and mass is molar mass. So for STP, or for molar, when you have the molar volume, is STP is the temperature and the pressure. Give standard temperature and pressure. So we already have the volume at STP for 1 mole. We have the mass for 1 mole from the periodic table. So basically, the value for density, it becomes a given value, because we get this from periodic table and we get from the definition of the molar volume at STP. Any questions? Questions? No questions? So in this example, if you want to calculate the density for N2, you want to calculate the density, you want the definition for density. Density is mass over volume. Okay, mass over volume. Now, how do we find the mass? Mass, it's the, if you have the number of moles, is going to be number of moles times molar mass. And do we have the number of moles in this case? It's not given directly, right? Number of moles is not given directly. What do we have? It says that we have the we have temperature and we have pressure. So if we have the temperature and pressure, if we don't have the volume, okay, if we don't have the volume, how can we get number of moles? It gets the, if you don't have the volume, but do we have the density for nitrogen? If the density is given at a temperature, density can change at the higher temperature. So how could you find the, so we want to find the density, this case. Rearranging of this formula of PV equals nRT. let's start from that. PV equals nRT. What is N? The value for N is basically mass over molar mass. Okay, that's the value for N. So we have the PV equals mass times R times T over molar mass. Okay. So if you want to get the mass divided by the volume, if you re-extract this, it's going to be or rearrange this. Volume equals, so I'm going like more stepwise than the PowerPoint, equals mass times RT times, or divide by the pressure molar mass. Okay. We're trying to rearrange this in order to get the formula for density. So if you want to rearrange this, the mass, to bring the mass down here, let's put it this way. If you bring the mass, I have to rearrange it the other way. The pressure times molar mass equals mass times times RT divided by the volume. So that becomes your density. Okay. So as long as you know the cross multiplying factor that we were talking earlier, PV times molar mass equals mass times RT. And you can rearrange that in a way that you can get the formula for density somewhere in this equation. So you have your density now. To find the density, you are going to divide both sides by RT. So density is going to then be pressure molar mass divided by RT. So we want to find the density at a different temperature compared to the STP. This is a density. If you had the density at STP, it would be just molar mass divided by 22.4. But this is a density at a different temperature. You have to come up with the formula for density using the ideal gas law. So these steps, if it does make sense, go through the steps. If it doesn't make sense, memorize this number, the formula. Density is pressure molar mass over RT. And since we are using the value for R in this case, the value for R is given based on the ATM and liter Kelvin. Everything else has to be converted. So temperature must be converted to Kelvin. So plus 273. Millimeter mercury cannot be used. It must be divided by 760 to give us in ATM. So pressure must be in ATM and the temperature must be in Kelvin. The molar mass, so if we have the pressure, we have the temperature, the R is a constant value, molar mass, because it's a nitrogen, we know that from the periodic table, you can now calculate the density. So indirect information is given for you to calculate density. To find the molar mass of a gas, that would be mass in grams divided by number of moles, basically rearranging the formula again. So number of moles equals mass divide by molar mass. If you want to find the molar mass, this would be like for unknown gas. Let's say you have a sample that you don't know what is the nature, what's the name for the compound. Then if you find the molar mass, from the molar mass, you can identify the sample. If you have a doubt that if it's compound A or compound B or compound C, you find the molar mass and then see if the compound, if it does match with mass of the compound A, if it does match with the molar mass for compound B or C, then you can identify your compound. Or if you have a newly, discovered compound that you want to find the molar mass for it, then you can use this formula. You can just rearrange this formula. So if you want to find the molar mass and the mole is going to be switched around. So molar mass is mass over number of moles. It's coming from original formula of number of mole equals mass over molar mass. And how do you find the number of moles? To find the number of moles, you need PV equals nRT. You rearrange this, N equals PV over RT. So basically, for a gas, if you can calculate, if you can measure the pressure, you can measure the volume, you can measure the temperature, you can find the N. And you can measure the mass in grams, because mass in gram, you're using a scale to measure the mass in gram. So if you have like an empty container, is empty, and then you have a container, then you have the container plus the gas, okay? You get the mass of this empty container, you have the mass of container plus gas, you subtract, that gives you the mass of the gas. So if you can find the mass of the gas experimentally from the experiment, experimentally you can measure the pressure, you can measure the volume, you can measure the temperature, then you can basically find the molar mass. There is an experiment designed for this, and that is actually experiment 10 and experiment 11 from 1045 that you actually have to do this calculation there. So based on the experimental values, you can determine the molar mass of a sample, gas or liquid that has changed to gas. Let's see if there is an example that is not solved. Calculate the density of a gas at temperature, pressure and temperature is given, and the how would you solve this problem? What are the steps? What do we need in order to find? We are trying to find the density. What do we need to find the density? We need for density. Okay, let me see what I have here. We have to change the torr to ATM and C to Kelvin, perfect. So plus 273. And then this divide by 760. And do we have the volume? We don't have the volume. First, we have to find the volume. How do you find the volume? Thank you. V equals nRT over P, right? Because PV equals nRT. You rearrange it to find the volume. And in this case, we have the number of moles, which is going to be 0.250 times value for R is given is 0.08206 R, and then the temperature is going to be 300 Kelvin. Divide by the pressure, and what is the pressure? 775 divided by 760, almost 1, but that's a 0.0197 ATM. And I put that up here for record, 1.0197 ATM. So we know where that number is coming from. And this one is going to be equal to 300 Kelvin. So we have these numbers, so we know where they are coming from. So if we have the volume calculated from this ideal gas law, and to calculate the volume, you just multiply these numbers and divide by 1. I have that number is a 6.03 liters. We have the mass also. So density is mass over volume. Mass is 9.988 grams over volume, which is 6.03 liters. Just remember, density for gas, the unit for density for gas is gram per liter, is not milliliter, because the value for volume or the mass per unit is very small if you do milliliter. So to have more workable number, they use the unit for the density as the gram per liter rather than gram per milliliter. For liquid is gram per milliliter, and for solid is gram per cubic centimeter. So just pay attention, because I don't want, the volume that is used here to be in milliliter. And that's how you find the final answer. And I have that number, 1.65 gram per liter. And this is the density for the sample gas that is given here. Okay, questions? Perfect, very good, very good. So you find the volume from ideal gas law, and then you have the mass. You can calculate the density. When you have mixture of the gases, then the idea of partial pressure and total pressure, it's in discussions. Gases, they exert pressure independently from each other. So if you mix gas A plus gas B, the moles of A would give you the pressure from A, moles of B would give the pressure from gas B, and the total pressure is the adding up the pressure of each of the gases together. So if you have the moles of A, that is going to give pressure A, moles of B, that gives pressure of B, the total the total pressure is going to be pressure A plus pressure B. Or you could add up the number of moles of A and number of moles of B, then you have a total number of moles. You can calculate the total pressure. So remember, these two corresponds to each other. Total pressure comes from total number of moles, and partial pressure, this is like P pressure just for B is coming from moles just for B. If you pay attention to this relationship, these two together, it kind of makes sense. If you're dealing with total number of moles, you get total pressure. If you're dealing with only number of moles from one gas, that gives you the pressure coming from that specific gas. You also have mole fraction. Mole fraction, the number is going to be between 0 and 1. And mole fraction is the number of moles for one gas. So number of moles, like let's say Na, you have divide by Na plus Nb. So what fraction of the mole is coming from gas A is just the number of moles of A divided by the total number of moles. And with that, since you have the mole fraction, you can also say what fraction of the pressure is coming from gas A, what fraction of the pressure is coming from gas B. Okay, I should keep my promise, as I said that I will stop here, but I wanted to just at least refer to it so you know that it's the partial pressure and the total pressure is kind of related. So if you want to find the partial pressure, so I'm going to actually, as I promised, I'm going to stop here, and I ask you to continue on the PowerPoint for this unit. I will post a video for the next unit. Thank you and have a